Example 3, we're solving tangent squared x plus tangent x minus 2. And when I look at this problem, I can see there's more than one variable term, and so I immediately know I'm not going to be able to isolate. I want to isolate because that's easy, but I know I can't. And so when I look at this one, tangent squared x plus tangent x minus 2, I guess you need to train your eye, but it kind of looks to me like this. I don't know that you want to write that down, waste space, but that's what this looks like. It looks like one of those trinomials that we've factored 1,000 times from Algebra 1 class. Remember where you have to find two numbers that multiply to negative 2 and add up to this positive 1 right here? And so you'd say, well, that's x plus 2 and x minus 1. That's how that would factor. And so then we would solve this and say there's going to be a negative 2 and a positive 1 would be our solution. Now, that's not exactly how this works because it's not a variable of x. We're really solving for that tangent x, and then we're going to do an inverse tangent at the end to isolate x. Okay? So, but keep in mind, that's exactly how this is going to work. The tangent x function acts as the variable. And so once you recognize that this will factor, instead of saying x and x, you would say there's a tangent x and a tangent x. We need two numbers to multiply to negative 2 and add up to this 1. And that's going to happen the exact same as what it did in Algebra 1 class. You're going to need a plus 2 and a minus 1 in order to get there. And so what we've just done is we've factored a trig function. We want to try and factor that so we can solve that. And what happens here, zero product property says that you'd either have tangent x plus 2 equals 0, or you'd have tangent x minus 1 equals 0. So what we have now are equations with only one variable term in them. Each of those two equations can be isolated. Now, if I looked at the one on the left, I'm going to subtract 2. I'd have tangent x equals negative 2. If I looked at the one on the right, I'm going to add 1. I've got tangent x equals 1. The one on the right is going to be easier to do because that's a chart question. That comes straight from the chart. You should recognize that one from the chart is going to come from the middle here. Tangent is sine over cosine, so we're taking square root of 2 over 2 divided by itself. And so you might say that's a 45-degree reference angle, right? You gotta be careful though, because this problem isn't in degrees. So you wouldn't want to say 45 degrees. You'd want to say pi over 4 there for your reference angle. But we'll do what and where, and so that's pi over 4 where tangent is positive, because that's a positive 1. The tangent ratio is going to be a positive, okay, is positive 1. And so we're looking at a pi over 4 where tangent is positive in the first and third quadrant. All students take calculus, right? All students take calculus. We know tangent is positive in the first and third quadrants. So there's a pi over 4 in the first and a pi over 4 in the third. So the first quadrant just is what it is, pi over 4. The third quadrant, remember how this works, halfway around is pi. To get a common denominator, we'll call that 4 pi over 4. And so that third quadrant angle is pi over 4 past 4 pi over 4. That'd be 5 pi over 4. So there's half the battle, 2 of your answers. Now the other equation is a little bit harder because it's not from the chart. So maybe you want to use a calculator. And with our calculator, we're just going to do inverse tangent of negative 2. If I want to solve this, I know I can do an inverse tangent of both sides. So x is going to equal inverse tangent of negative 2. So let's make sure we're in radian mode. We're going to do an inverse tangent of negative 2. And you have to be smarter than your calculator here, because that answer it spits out is not the answer. It looks like we have a negative 1.107, but you have to remember the what and the where. Really, that's talking about a 1.107 reference, and that is an angle. That's a reference angle where tangent is negative. Is that right? Because we see the tangent ratio is talking about a negative 2. We're talking about a 1.107 where tangent is negative. You're not allowed to have a negative answer anyway, right? This interval says that our answer has to be in between 0 and 6.28. So if you gave me negative 1.1, that's definitely not going to be right. So you have to look at that 1.107 where tangent is negative, meaning quadrants 2 and 4. And so we've got a 1.107. I rounded off in the second and a 1.107 in the fourth. So think about what that means. Okay? A little bit difficult, I think, with the decimals there. But halfway around, we know halfway around is pi. And so if I'm looking at that angle in the second quadrant, it's going to be pi minus that 1.107. So we can do that. We do pi minus 1.107. It's about 2.035. So we've got 2.035. That's your second quadrant angle. And then you've got the other one, the one in the fourth quadrant. Remember, all the way around is 2 pi. So it's 1.107 before you get all the way to 2 pi. 6.28 if you're estimating there. So let's do 2 pi minus 1.107. 5.176. 5.176. So we have 4 answers here in that interval from 0 to 2 pi. We have 4 answers. And I don't know about you, but I'd much rather deal with the ones that have that pi over 4 in them than the ones with the decimals. The decimals kind of play with our brains and make it look kind of difficult. But you could have decimals, you could have pi over 4 stuff. As long as you're in radians, that's it.